Elsewhere among this breakdown of the various topics you'll want to know, you may have come across questions where you'll be given an equation and you need to plot them onto a graph. So you take your given x value, put it in, get a y out. It may be in a table. I always think those are helpful to represent things. And then you'll just plot those coordinates on and join up the dots in either a straight line or a smooth curve. There are some graphs, however, that the exam would just like you to know the shape of already. And that's what we're going to be going through here in this video. To start off with, we'll be going through the graphs of the trigonometric functions. So this is our sine, cos, and tan, which you may know from SOHCAHTOA. For the sine graph, so that of y equals sine x, we're going to have this axis here, as you can see for all the trigonometric functions, potentially going between minus 360 and 360 in intervals of 90, and then going up to 1, and then down to minus 1. Well, that's that last bit for the sine and cos. Tan is slightly different. We'll get to that in a second. So for the sine graph, we're going to start at 0, 0. And then we're going to go up to 1 at 90, back down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. This then goes the other way in the negative, so at minus 90 will be at minus 1, minus 180 is 0, minus 270 is 1, and again, minus 360 is 0. Just joining these up then, you end up with a wave-like graph going up and down in your intervals of 180, getting back to that x-axis every 180 degrees you end up putting as your x value in that function. As for the cos graph, so y equals cos x, we're this time going to start up at 1 when x is 0, rather than in the middle. It's then when we get to 90 that we're down at 0, 180 is done at minus 1, 270 back to 0, and 360 back to 1. Going the other way, so now at minus 90 we're down to 0, minus 180 is minus 1, minus 270 is 0, and minus 360 is 1. Just joining these points up, once again, we end up with a wave. And you may notice, actually, that this is the exact same kind of wave as was in the sine function. However, this time, it's been shifted along by 90 degrees. You could say like the sine is shifted to the left by 90 degrees. So this 91 becomes 01, and so forth. Not only that, here we can see the cos graph is symmetrical. Whether the x value is positive or negative, it's going to give that same y value. And then again, in general, it's going through the x-axis in 180 degrees. It's just this time it's on the 90 to 70 rather than the 180, 360. As for the tan graph, as has already been said, this is going to be slightly different again. Here we're going to start at 0, 0, but then at 90, we're not going to have a point, we're going to have an asymptote. That is to say, an imaginary line which the curve is never going to meet. This asymptote then again appears at 270, at minus 90, and minus 270. In the middle values in between these, so at the 180, the 360 in both positive and negative, the graph is then back at 0. But if the graph isn't touching these imaginary lines, how can it possibly connect up? Well, if we just start at 0, it's going to start shallow, but then increase exponentially until it becomes so steep that it would be going at an infinite gradient. Then it loops back down to the bottom, starting very steep, but then becoming shallow, flat at 180. At which point, it then starts going up again, so repeating what was between 0 and 90. Then from the bottom of 270, it appears again and levels off to cross at 360. Similarly, on the left-hand side of 0, we're now going to start shallow, but then drop exponentially, come up on the left-hand side, of the minus 90, dropping down, level at minus 180, and then we come down again, getting steeper and steeper towards minus 270, appear on the other side of 270, and come in shallow for the 360. This is what the tan graphs look like. This is why, if you were to do tan 90 or tan 270 or whatever, your calculator will give you a math error. There just is no value for it. And you can see here, once again, it's a graph that loops every 180 degrees, like these previous ones have been. Yeah, so just as you're going through your questions, you may be asked, draw the sine graph from 0 to 360. Draw the cos graph from minus 180 to 180. And you'll just need to be able to say, okay, this is the general shape. Whenever a question is saying sketch, it doesn't have to be absolutely 100% perfect. But you need to get the main coordinates down. So you need to know, okay, where is it crossing the x-axis in any case? Where is it crossing the y-axis in any case? So long as you have correctly identified those coordinates and the general shape is correct, you would get the marks for that sketch. Just one other thing, though, that I also want to mention while we're still looking at these trigonometry graphs, is that as well as the exam may be wanting you to know what the shape of the graphs is, they may also want you to know what certain exact values of sine or cos or tan given angles are. And what I mean by that is, you may be expected to know what sine of 0 degrees is, 30 degrees is, 45 degrees, 60 degrees, and 90 degrees. Well, for sine 0, we can see here that's just 0. Then sine 30 is a half. Sine 45 is root 2 over 2. Sine 60 is root 3 over 2. And then sine 90 is 1. For cos, cos of 0, we can see here is 1. Then cos of 30 is root 3 over 2. Cos 45 is root 2 over 2. Cos 60 is a half. And cos 90 is 0. And as you may be able to see here, therefore, the sine and cos values that you're expected to know are just the same as each other, just in the reverse order. Now then, just for the tan graphs instead, tan 0, once again, we're at 0. Tan 30 is root 3 over 3. Tan 45 is just 1. So there technically would be a 1 on this axis, but because you then extend infinitely above and below that, you don't have to mark it on the axis. Tan 60 is then just root 3. And tan 90, yeah, because it's an asymptote, it's infinite, it's undefined, it has no value. Yeah, so you just maybe want to be familiar with all of these values as well. If we're happy with that then, let's turn on to the next type of nonlinear graph, which would be an exponential graph. This I would actually like you to do on your own. First of all, I mentioned already that certain questions will have, okay, so plot this the graph with this equation, and you'd have to, okay, so if we have this x value or this y value b, so maybe come up with a table of x and y. So for some given x is, okay, this is corresponding y, and then when you have enough values, plot them onto the graph. Whether or not you know what an exponential graph looks like already, I would like you to draw a sketch of y equals 2 to the power of x. And it's x being in the power that's making exponential here. Have a go for yourself, pause the video, probably like drop this out on a piece of paper of your own, and then when you're ready, press play again and we can compare. Alright, so maybe we're going to take some values such as minus 1, 0, 1, 2, 3, and 4 for our graph. There are going to be some values centered around 0. It's up to you which ones you take. You could go up in 2s or less than whole numbers, but whatever. So long as you have enough that it then kind of indicates the shape. if you were to plug this in here, so 2 to the power of minus 1, that should give you a half. 2 to the 0 is 1. Anything to the power of 0 has a value of 1. 2 to the power of 1 is going to be 2. 2 to the 2 is 4. 2 to the 3 is then 8. And 2 to the 4 is 16. If we then just wanted to sketch this graph, and again, it's just a sketch, it doesn't have to be accurate, so I'm just going to do a small one here. If we're crossing then, when y is 1, when x is 0, then over here from minus 1, that's going to be a half. Then going up in those same intervals, we're going to go from 2 to 4 to 8 to 16. Like each of these is then doubling in height. Even though I can't actually already get to my 3 and my 4 on this sketch, we can already see the shape is forming this kind of curve. Where in the negative, this is getting shallower and shallower, getting closer and closer to 0, but never touches it, because there's no possible value of a power that can make a value then equal 0. It always then crosses at 0, 1. Regardless of what this number here is, anything to the power of x as a graph always goes through the point 0, 1, because anything to the power of 0, as I said, is 1. Then on the right-hand side, we're just then getting rapidly steeper and steeper and steeper. You can put on your scale on your x-axis and your y-axis to say the 1, 2, 3, 4, the 2, 4, 8, 16. But so long as the shape is there, and so long as you have marked that coordinate as 0, 1, that is primarily what they'll be looking for from your sketch of any exponential. Okay. If we're happy with that, let's turn to an actual paper question. So in this question, we've got a couple of graphs they're looking for us to draw. First of all is the graph of x squared plus y squared equals 4. Now, even when you've been doing other questions where you have an equation to plug values in, they may not even still have looked like this. This is a very specific graph where you've got both x squared and y squared on the same side. The easiest way to do this is just to take x and y, or one of them at a time, as 0. So, if x equals 0, then 0 squared plus y squared equals 4. Well, 0 squared doesn't have any value other than 0, it's not adding anything, we can just ignore it. So y squared equals 4. So y equals the square root of 4, which is 2 or minus 2. Whenever you do any square roots, there are always two answers, one positive, one negative. With that in mind, therefore, okay, when x is 0 and we're here, y is either 2 or minus 2. Then, if we instead take y as 0, then that's going to be x squared plus 0 squared equals 4. Once again, the add 0 squared is adding nothing, so we can just ignore it. So we have x squared equals 4, so x equals root 4, which yet again is going to be that same 2 or minus 2. So when y is 0, x is then either here or here. To do any other values in between is going to give you surds, which are, if you haven't seen that video or aren't familiar with them, square roots that don't come out nicely. So if we try to, okay, x is 1, okay, well, 1 squared is 1, so 1 add y squared equals 4, minus the 1 over to the right hand side, so 4 minus 1 is 3, y squared is 3, y is root 3. Root 3 is not a nice number, that would be really awkward to plot. And actually, any others are going to get you that same problem. So if you have something like this, which is x squared and y squared together, just do when x is 0 and when y is 0 to eliminate one of them. Now that you have these, well, what could this possibly be? Because you've got points both on top and bottom and left and right on the same plane. Well, actually, what this is then is a circle. No. Yeah, so you've got, your extreme points at north, south, east, and west, and then this just loops around in a circle around center 0, 0. As for then this one down here is just on the grid, sketch the graph of cos x from 0 to 360. Okay, well, if we just remember from above, so our cos 0 started at 1, then it goes down to 0 at 90, minus 1 at 180, 0 at 270, and 1 again at 360, We're not going to go up to the 450 because that's not in the domain it's asking for. So if we just curve this down here, there, that would be the graph that you had to draw. This is how we just use our knowledge of given the shapes of graphs to just sketch them on grids if they're given to us.